Hi everyone, today starts our brand new section on writing quadratic functions. And what's nice is that by the end of the lesson, I'm hoping we have discovered that much of this we already know. I'd say probably 3/4 is prior knowledge that we're going to bring back and make some new connections to this concept of writing a quadratic function. So if you notice, the very first title here says, recall the relationship between factors and zeros. So we have these two vocab words that we'll be looking into. The directions say factor, find the zeros, and sketch the quadratic function. So before we come back to discussing what these vocab words are, let's follow these directions. Factor. So to do that, we will set this equal to 0, because eventually I'm going to be asked to find the zeros. So setting this equal to 0 becomes 0 equals x squared minus 3x minus 18. Bringing back my factoring knowledge, I remember that there's an invisible 1 right here. If you want to write it in, you can, or don't. So off to the side, let's make a little note. Factoring a equals 1. So we recall, to factor when a equals 1, we need factors of C that add to B. So in this case, I'm looking for two numbers that multiply to negative 18 and add to negative 3. And what's nice is that I can actually kind of keep track of my ideas off to the side. So when I think of 18, for me the first factor pair that came to mind was 2 times 9. And I've noticed that C is negative, so to multiply to a negative number, one of these factors has to be positive and one of them has to be negative. So let's say I make 9 negative. Negative 9 and a positive 2, when I add them together, I get a negative 7. If 2 was positive and 9 was positive, so 2 negative, 9 positive, adding those together, I get a positive 7. So it doesn't matter which one of these is negative, I either get a 7 or a negative 7, which is not what I need. I need the negative 3 in the middle. So I'll just gently cross those out. I still want to be able to read it, so I remember that I already tried 2 and 9. Then I might think, well, how about 3? 3 goes into 18 6 times, so 3 times 6. 1 has to be negative, and to get a negative 3, which of these should be negative? Which factor should be negative, so that when I add these two numbers together, I get a negative 3. I'm hoping we're thinking to ourselves, 6 needs to be negative, and I would agree with you. 3 times negative 6 equals negative 18, and when I add 3 and negative 6, I would get negative 3. So this factors to be x plus 3, x minus 6. And you could have put x minus 6 first. X minus 6 times x plus 3 would be the same. So we have successfully factored. Let's keep track of this. We factored as of this step. So if I had just asked you to factor, you'd be done right there. Make this a different color. As of this step right here, we factored. Then we're asked to find the zeros. To do that, we need this set equal to 0, and that's actually something we did in advance because we knew we were going to be doing this. To find the zeros, a great way to think of it is literally zeros and the number 0 are connected. So if I'm asked to find the zeros, I set this equal to 0, and then I ask myself, how can I solve this? Well, I see that this is being multiplied. I've got this factor times this factor. Whatever value of x makes this first factor 0 would make this whole thing 0. So I'll take x plus 3 and I'll set that equal to 0. Solving this, I would subtract 3 from both sides and get x equals negative 3. So here, let's see what happens. I got x equals negative 3. What if, don't do this with me, just watch. If this was negative 3, if I plugged in negative 3 for x, what is negative 3 plus 3? Well, negative 3 plus 3 equals 0. 0 times anything is 0. So that's my first zero. Let's take x minus 6 and repeat the process, because there's a value of x that will make this factor 0. So solving x minus 6 equals 0, I'll add 6 to both sides. And I get x equals 6. I can mentally check that out here. 6 minus 6, that's 0. 0 times anything is 0. So I have successfully found the zeros. Zeros are x-intercepts when I graph. So zeros and x-intercepts go together. So x equals negative 3. On the x-axis, I'll go 1, 2, 3. That's my first x-intercept. And then 6. 1, 2, 3, 4, 5, 6. As ordered pairs, this would have been negative 3, comma 0. Right? Because I started at 0, 0. I went left 3 and I did not go up or down at all. And this one would be 6, comma 0. Again, I went right 6 and then I did not go up or down. We technically have the ability to find the vertex, but this is just a quick sketch. So I'm just going to use A to tell me how this should look. Is A positive or is A negative? It's a positive A, so I know that it will open up. So we can finish this quick sketch by sketching a parabola. Not liking how this is coming out. Parabola that opens up. So we've started to experience the connection between factors, zeros, and x-intercepts. Here I have my factors, x plus 3, x minus 6. The zeros come from setting each of these factors equal to 0. You can think of it as these are the two x values that if I plugged in, it would make a factor equal 0. And when I find these algebraic zeros, these values that would cause a factor to be 0, those are connected to the x-intercepts on the graph. Here was negative 3, and here was 6. So let's actually formally write down that concept. It says, what is the relationship between zeros, or x-intercepts, of a quadratic function? And I think this is actually supposed to say factors, and it's factors. So if you can cross that out and write factors. The zeros are found by setting the factors equal to 0 and solving for x. The zeros are the x-intercepts on the graph. So the zeros are found by setting the factors equal to 0 and solving for x. The zeros are the x-intercepts on the graph. Let's now see how this will be connected to writing a quadratic function using zeros. And if you have your highlighter, it would be great to highlight this title, because it is the focus of our learning in this lesson, is how to write a quadratic function using zeros. And we have 2 steps in this process. So step 1, we will place the 0 in the factor, subtracted from x. So that will look like x minus the 0 you plug in. Step 2, distribute the factors combine like terms, and write in standard form. So what we're saying is that we're going to start with 2 numbers, and I'm literally just going to use a number sign to keep it general. So I'll be given 2 numbers that I'm told are the zeros, meaning they're the x-intercepts if I was graphing. I'm going to set up the factors. It says place the 0 in the factor, subtract from x. So it'll be x minus each of those zeros. And then to finish it off, I will then use my distribution skills to distribute and combine like terms. And when I'm done, I should be able to have a quadratic in standard form. So let's see how this is going to work with our first example, and I'm going to make sure that these steps stay in sight for number 1. The directions say write a quadratic function in standard form using the given zeros. So I know these are the x-intercepts of my graph, which is important because I can use them to work backwards to write the actual function. So step 1 says place the 0 in the factor subtracted from x. So that's going to be x minus 7, x minus a negative 4. So notice these minus signs are not optional. So the fact that 4 was negative means I'm now going to have 2 negatives there. So I could rewrite this as x minus 7, x plus 4. We've accomplished the first step. We've placed the zeros in the factors, subtracted from x. And then to finish this off, it says distribute the factors, combine like terms, and write in standard form. So we're going to have x times x, which is x squared, x times a positive 4, plus 4x. Nowhere else to send the arrows from x in here, so now we'll distribute negative 7. Negative 7 times x is negative 7x. And negative 7 times a positive 4 negative 28. We're so close. What's the very last thing we can do to finish this? We can combine like terms. So my final answer will be f of x equals x squared. Positive 4 and a negative 7 is negative 3x when I combine like terms, minus 28. And we'll put our final answer in a box. And we're done. So if you compare what we just did in number 1, where we started with the zeros and we ended with our function, it's almost like we did our warm-up backwards. Here, we started with the function and we worked down to get the zeros to be able to graph. Now, we're starting with the zeros and ending up with the function. So compare and contrast. Here I started with the zeros and I ended up with the function. Here I had the function and worked towards getting the zeros. So this is our prior knowledge. We've done this. Starting today, we're learning how to work backwards. How to start with these zeros and end up with the original function. Let's try number 2. The process does not change, so again I'll leave step 1 and 2 on the screen here. Place the 0 in the factor subtracted from x. So it's going to be x minus 0. And then what's this one going to be? This one's going to be x minus 8. Now x minus 0, I could work with that, but subtracting 0 doesn't actually change anything. So we could just write this as x times x minus 8. And then next, distribute the factors, combine like terms, and write in standard form. So x times x is x squared. X times a negative 8 is minus 8x. And there's nothing else for me to distribute. So I'm actually done, because when I look for like terms, this is x squared and this is x. So recall, like terms means same variable raised to the same power. So I have the same variable, these are both x, but notice, what's the power here? Here the exponent is 2, and then here, remember, x is technically x to the first power. So that has 1 as an exponent. These are not like terms. I can't go any farther. Please try setting up number 3 on your own. Try setting up number 3. So this will be x minus a negative 2. And this will be x minus a negative 6. So once again, focusing on the fact that it's always going to be x minus the 0. X minus the 0. If I plug in a negative 0, we will have the double negative situation. So this will become x plus 2 times x plus 6. Please press pause and work through the distribution, and we'll see if our final answers match. Press pause now. So let's see, I distribute x to both terms here, and I get x squared plus 6x. And then distributing 2 to both terms here, that becomes plus 2x plus 12. Looking for some like terms, I see them here in the middle. And my final answer is f of x equals x squared plus 8x plus 12. if we matched. Give yourself a little smiley face on that. Nice job. Number 4 changes it up a little bit, but we're actually going to see that this is really easy. It says x equals 9 repeated. What do you think repeated means? What does it mean for something to repeat? It means it's going to happen more than once. So repeated means we have x equals 9 twice. So if I were to write that out, that's going to be x minus 9 times x minus 9. We literally have 9 twice. Again, press pause, finish it from here, please. So distributing x, I get x squared minus 9x. Distributing negative 9, we get negative 9x plus 81. Combining like terms, f of x equals x squared minus 18x plus 81. And once again, if we matched, nice job. Let's build on this a little bit. Next, it says, write a quadratic function in standard form using the given zeros and characteristic of A. So we're going to have a new piece here, but again, very much connected to our prior knowledge. So let's first start off on what would we do if it says zeros are x equals negative 3 and x equals 5. So go ahead and set that up with what we know how to do right now. How would I write my factors given these two zeros? If we're comfortable, I'm okay when you see a negative. If you are comfortable immediately writing x plus 3, I'm cool with that too. If it still helps you to write x minus negative 3, which then turns into a plus, that works as well. So this is how I would write my two factors given these two zeros. Notice now I have this characteristic that says it has to open down. So if it opens down, what do I need to remember about A? Well, I know if A is negative, then it's going to open down. So we actually get to pick whatever negative A value we want. Notice it says, write a quadratic function. There's many quadratic functions that have these two zeros and open down. So I would go with keeping it easy. And let's just let A be negative 1. So we're going to write negative 1 out front. If you have a highlighter, it would be good to highlight these two so we understand where they're connected. To do the algebra, we're going to let negative 1 hang out front. We're kind of put it on the back burner. It's still going to be there, but we're going to deal with it last. So for right now, negative 1 is out front, and please work on distributing and combining like terms for x plus 3 times x minus 5. I'm not going to ask you to press pause, but I will ask that you not look at the screen while you work on distributing x plus 3 times x minus 5, and I will be doing so quietly while you work. So let's check in with each other and see if we match. If we don't, see if you can go backwards and find what happened with the algebra. And if you're still not seeing it, no worries. Press pause and shoot me a quick question on Remind. Now that I've done everything I can on the inside, I will now address this negative 1 by distributing it to each term on the inside. So my final answer will be f of x equals negative x squared plus 2x plus 15. Now, all I was told was that it opens down. If you're ever just told opens down, the fastest way to create that quadratic would be to just let a be -1. Let's follow this concept through to our next example. Number 6 says zeros are at x equals 4 and x equals 6. And now I have the characteristic here of being more narrow. So what does it mean if the graph is more narrow? Well, for more narrow, I recall from my prior knowledge that a has to be greater than 1. So what's the nicest number greater than 1? Keeping it small, but bigger than 1. I vote let's let a equal 2. Now you could let a equal 3 or 4 or 5, but the larger the value, the possibly slightly bigger the numbers are going to get as we go. So we want to be efficient with our time. 2 will get the job done just fine. So once again, that new a value will go out front, so it's going to be 2 times. How do I write the factors given these zeros? Give it a try, and then we'll see if we match. It's going to be x minus 4, x minus 6. Just like last time, we're going to leave 2 alone. Oh, if you want to highlight it so you remember where it came from, the fact that a has to be more narrow. Leave 2 outside, and please work on distributing x minus 4 times x minus 6. Once again, while you're working on your paper, I will work here. Please don't look up until you're ready to check answers. If you know you're going to need a couple extra seconds, press pause if you hear me talking and you're not done yet. I finished distributing. Do we match? If we do, great. We are good to go to move forward. If we don't match, see if you can press pause and figure out where's the difference. Distributing in 2 to finish this up. My final answer will become what? Let's see if we can say it together at the same time. 2 times x squared, that's going to be 2x squared minus 20x plus 48. So I have successfully written the quadratic function for a graph that has x-intercepts at 4 and 6 and is more narrow. Number 7, I actually have 2 characteristics. It says opens down and narrow. So opens down means what? What does that mean about a? Well, that's going to be a negative a. And more narrow, so a has to be greater than 1. And this is where writing those absolute value bars might help you out. Because if you don't, you might think to yourself, wait, how can a be negative and greater than 1? Remember that when we talk about narrow and wide, we're just talking about the actual numerical value of a. Ignore positive or negative. That's what it means to just focus on the absolute value. Being as efficient with our time as possible, what is the smallest negative number I could work with that would satisfy this opening down and more narrow? That would be -2. It's negative, and the absolute value of -2 would be 2, and 2 is greater than 1. As we have for our previous 2 examples, this -2 will just hang out front all by itself until we are done taking care of the zeros. So negative 1 and negative 11, go ahead and write the factors that would come from that. Once again, if you're comfortable seeing that this is negative and knowing that we're going to get a plus 1 here, feel free to do that now. Or, if you're not sure where that came from, then it's perfectly fine to stay with x minus and then plug in the negative 1. And on your next step, minus minus will turn into that plus. Same will happen when we plug in a negative 11. X minus minus 11 will turn into a positive 11, or x minus a negative 11, whichever way you want to see it. Either way, we get a positive 11. I'm going to leave this one for you to finish, and I will check answers with you tomorrow. Let's move on to setting up number 8. The restriction here says more wide. More wide. So for more wide, I know that A has to be between 0 and 1. So if I had to pick a fraction between 0 and 1, what's the nicest one I could think of? Well, if you're thinking 1/2, me too. So let's work with A as 1/2. Again, you could choose 1/3, 1/4, any fraction you want between 0 and 1. 1/2 will stay out front, and then turning our zeros into factors, this will be what? Does anybody remember what this became when we had it last time? Technically it's x minus 0, but x minus 0 is just x, so you can leave it for the first step if you want, but realize this will just become x, and then minus a negative 12 will become a plus 12. On this next step, let's get x minus 0 just as x, and then times x plus 12. I will also leave this one for you to finish and check answers with you. Let's move into the last two examples that are part of this lesson. Now we are starting with graphs. It says write a possible quadratic function of the given graphs. Well, let's look where we started when we were given numbers. In 5, 6, 7, and 8, I started with information about the zeros. And remember, x-intercepts are zeros. I can turn zeros into factors. So this is the big idea. Where are my x-intercepts for this graph? Where are they? I see one at negative 4 and another at 2. So my zeros are x equals negative 4 and x equals 2. Sometimes you might actually see them just listed negative 4, comma 2. That is not an ordered pair. That's a list of zeros. So look at our big idea. X-intercepts are zeros. I can turn zeros into factors. How would I turn these zeros into factors? Well, I know negative 4, that's going to be x minus a negative 4, which turns into x plus 4, and then x minus 2. Notice again it says write a possible quadratic. and that's because we are not looking for the vertex to be exact. What I do need to make sure is correct is whether or not this opens up or down. This graph opens up, so I need a positive a value. Keeping it nice and easy, we'll let a be 1. So for this one, you technically could put a 1 right here, but we don't need to because multiplying through by a positive 1 doesn't change anything. So to finish this up, we just need to multiply. We'll get x squared minus 2x, and then distributing in the 4, positive 4, we'll get plus 4x minus 8. Combining like terms, x squared plus 2x minus 8. Now this is a great place to just pause real quick and say, well, what if it had been opening down and I had a negative a, so a was negative 1? Then I would have had negative 1 hanging out front this whole time, and my final answer wouldn't be complete until I actually sent in that negative 1. And I mention that because it's going to come up in our last example. Because notice this graph opens down. So once again, the big idea hasn't changed. X-intercepts are zeros, and I can turn zeros into factors. So where are the x-intercepts of this graph? I see one at 1 and another at 3. So let's get our list. Our list of zeros are 1 and 3. And notice this opens down, so we need a negative a. So keeping it nice for ourselves, let's let a be negative 1. Take a shot, please, at setting up the factors and remembering where does that negative 1 go. So setting up my factors, I'll have x minus 1 times x minus 3. That negative 1 needs to go out front. I'm going to ask that you finish this one. So at the start of class tomorrow, we will, if you have time, we will check answers. If you have time to finish these now, we'll check answers for 7, 8, and 9, or excuse me, 7, 8, and 10. Or those will be part of our warm-up for tomorrow. So finish now. Or the warm-up for tomorrow, we'll be checking our answers together for 7, 8, and 10. Great job. Those of you that do try 7, 8, and 10, if you have any questions, please send me a reminder, and we will continue next class. Have a great night.